This video is going to be about how to use Excel for some data analysis. So we're going to cover how to download class data, best practices for saving files, as well as how to use Excel for required calculations and standard deviation. We'll make sure that we cover how to change cells to display the correct number of sig figs, how to name cells and use basic formulas, as well as how to copy and paste from Excel into Word in a way that it looks nice and is nice and readable. So I'm going to start by navigating to LEFFELlabs.com. This is where all of your class data sets will be posted. And we're going to say that we are in Unit 1 for this video. So I'm going to go to Unit 1 there. And then under the laboratory section, there is the Excel file with the class data. So I'm going to go ahead and download and open this file. And then because I'm going to be doing a bunch of stuff to this file, I'm going to make sure that I save it. So I'm going to go ahead and go to my documents, and I'm just going to create a new folder where we'll do all of our AP chemistry work. This way we can save everything in one place and everything is nice and organized. So I'm going to just change this file name here to be a little bit more meaningful to me. So I'm going to call it 1 because it's Unit 1, and then I'm just going to say standardization of NaOH. And then I'm just going to call this data analysis because that's what this file is. So I'm going to make sure I save all of my files with a similar format here. This way they'll all be clustered together. So I'm going to do 1 standardization of NaOH and then something different. So every file related to this lab is all going to be together and in one place. And if you notice at the bottom here, there are tabs that have different class sets of data. So I'm going to say that I'm in class period 1A, so I'm going to select that tab. So I'm just going to zoom out a little bit so we can see a little bit more. First, we need to handle the actual data analysis here. So this particular lab is the standardization of sodium hydroxide solution using potassium hydrogen phthalate, or KHP. So an unknown sodium hydroxide solution is reacted with a known mass of KHP in solution. Phenolphthalein is the indicator, so once the endpoint is reached, we're going to see a faint pink color. This indicates that all the KHP has reacted. So the data that we collected, every group, there were 8 groups in this class, they recorded the mass of the KHP, as well as the starting and ending volume of the sodium hydroxide solution. So the calculation that I need to complete here is going to be to use the grams of KHP, convert that into moles of KHP, and then into moles of NaOH. And then if I divide by the volume of NaOH, that gives me moles over liters, or the molarity of the NaOH. So I'm going to start by finding the difference in these two columns here. So I'm going to do the ending volume minus the starting volume to get the total volume. So I'm going to name this total volume, and I'm going to put this in units of liters here. So I'm just going to put a capital L up there. You want to make sure that you name your columns something that makes sense so that immediately looking at that column, you know what that calculated value is. So to get the difference here, I'm going to first press equal sign. This tells Excel that I'm doing a formula here. And I need to take the ending volume minus the starting volume. So that's going to give me the difference in volume. And you see there, that gave me the difference, which is 16.26. But that's still in milliliters. So if I want to put this into liters, we know there's 1,000 milliliters in 1 liter. So I'm going to need to divide the milliliters by 1,000, and that's going to give me my volume. Now that looks a little funky, and the reason it does is because what Excel is doing here is it is rounding this to 2 decimals. I don't want it to do that. I want all 4 of these decimal places here. So I'm just going to click this button to increase the number of decimals that are shown. So I just did that for one of the values. So what I can do is grab this calculation and just drag it all the way down. And there I have very quickly calculated the total volume for all 8 trials. So since I have the total volume here, my next step is going to be to find moles of NaOH. So the way I'm going to do this is I need to convert grams of KHP into moles of KHP, and then it's a 1-to-1 ratio. So the moles of NaOH is exactly equal to the moles of KHP. So to do that, I'm going to press equal sign. I'm going to do an equation here. And I need to take my grams of KHP and I need to divide by the molar mass of KHP. And I'm just going to put some parentheses around this just to keep everything clear. So there we go. That's the moles of NaOH for all 8 groups. Now that we have moles and volume, we can go ahead and get the molarity of the NaOH. So to do that, I need to do moles divided by liters. And then once again, I'm going to click and drag this all the way down. So what we've done here very quickly is we've calculated all of the molarities for all 8 groups. So now what I'm going to do is I just want to make sure these are all showing me the correct number of sig figs. So I'm going to select these guys. The moles of NaOH came from the grams of KHP. These are all 2 sig figs. So this has to be 2 sig figs as well. So I'm just going to adjust this until it shows me 2 sig figs for all of these numbers. Now, even though the number that is displayed here is 0.0015 moles, all of those numbers before we took down those decimals, all of those numbers are still there. It's just that Excel is only displaying the first 2 sig figs. And then since this was calculated based on moles, which was 2 sig figs, this guy needs to be 2 sig figs as well. So I'm just going to adjust all of that down to 2 sig figs here. So if we look at our values here, they're all actually pretty close. We have a pretty good spread of data here. But if we want to really talk about what the molarity is and the best way for us to report the molarity, maybe we're going to use this solution in other labs, so we need to know the concentration very precisely. We're going to go ahead and do a standard deviation on these values. So standard deviation is just a measure of how spread out the numbers in a data set are. So if we look here, we see that we range from about 0.092 to 0.099 with a bunch of values in between. So that's a pretty small spread, but we can actually describe this with a number in a way that is much more precise. So here's the formula for standard deviation, and that might look kind of intimidating. It does literally have Greek letters in it. So we've got the sigma letter, and we've got a capital sigma, and this is the letter mu. So basically what this formula is telling us, it's these 4 steps right here. So first, we're going to find the average of the data. That's what mu represents. Then I need to subtract each value from the average and then square the difference. So that's step 2 there. Then I need to take those numbers and find the average. So I'm going to take the squared differences, add them all up, and then divide by how many values there are, and that's just going to give me the average of those squared differences. Then finally, we can take the square root here, and that's going to give us the standard deviation. So I'm going to need to name a few things here. I'm going to start by calling this the average molarity. So I want to find the average of all of these values here. So the way that I'm going to do that, I'm going to put equal sign and then type the word average. And then I'm going to select all of the cells that I want to find the average of. And there it is. There's our average molarity. And here it's already displaying with 2 sig figs, which is what we want. We could again adjust that up here if we felt the need to, but this is displaying the correct sig figs. So I've worked out the average here. And now what I need to do, I'm going to work over here on this column, is I need to take each of these values and subtract it from the average and then square it. So I'm going to call this difference squared. Just going to give it that name there. Let me kind of scoot over so that we can see everything. Okay. So what I need to do is I want to name this cell. So I'm going to go to formulas and go to define name and hit define name. So I'm just going to call this average M for average molarity. So I've now named that cell. So here I need to do the molarity minus the average molarity. So do you see how that highlighted in red? So what I've told Excel is every time I type AVGM that I'm referring to this cell, and that's the value that you should use. And I also need to do the square here. So I'm just going to put this in parentheses, and then I'm going to do a caret and a 2. That's how you do square in Excel. Okay, so there's my difference squared, and I'm just going to click and drag this all the way down. And if we check any one of these cells, you see I'm taking the molarity minus the average molarity and squaring it, so we can check another cell and we see that's all working. If I didn't name this cell, it would try to use the cell underneath it and the cell underneath it to fill in these values. Here, this is being displayed in scientific notation. If I want to change that, I can just go under number, under the home tab, and change this to number. And then because those were such small numbers, they're displaying as zeros. So I'm just going to increase some decimal spaces here, some decimal places, so I can see what that difference really is. Okay, so now that I have the difference squared, I now need to take the average of the difference squared. So I'm going to call this average diff squared. So this is the average difference squared. So I'm going to do equal sign and type in the word average. And then I'm going to select all of these cells. And that's my average difference squared. Then what I need to do to find the standard deviation in the last step here is I just need to take the square root of the average difference squared. So I'm going to type in SQRT for square root, and I'm going to select the cell, and there we go. So I just want to make sure that I see enough sig figs here. So since this goes out to the third decimal, my standard deviation should be to the third decimal place as well. So there we go. There's our standard deviation and the average molarity. So now that I have that all done, I'm going to go ahead and copy and paste this into my PostLab. So I just opened up a file and put the categories, the headings that I need here. So under data analysis, I'm going to want this data table. So I've just selected it. I'm going to hit Control C, and then I'm going to hit Control V. And it kind of is going off the page here. So I'm just going to fit to window. And then all of that, those numbers are going to show up there. And then I want to make sure that I put some nice columns and rows on here. I'm just going to adjust these things so that everything looks nice. I can change the font size. I can do a lot of things here. Let's make this a reasonable font size. And then since I hit fit to window, it's not letting me. So now that I've got this table here, all that I'm doing here, I'm just adjusting things so that everything looks nice and it's easy to read. So you can do a lot of playing with cells here until it looks nice. So there's my data table. I'm going to go ahead and center it, or you can do whatever you like there. So this is the data table that's for finding the molarity. And then I'm just going to call this other data table standard deviation value. values. So then I'm just going to take these guys here, paste those right in there. Going to give this all my columns and rows here. There we go. So then we could go ahead and put in that the final molarity value is going to be 0.096. And then I'm going to go ahead and put in the plus or minus symbol. So I'm going to go to Insert Symbols, and I have it right here. You can search for symbols under here. And then I'm going to just type in my standard deviation value. So just to review what we've accomplished in this video, we have used Excel to calculate the average molarity for calculations, as well as how to do the standard deviation. We've covered how to download class data and how to save your files, as well as some other Excel basics.